Hello everyone, my name is Lou Del Monte and welcome to Del Monte and Science. In our last video we were talking about the Big Bang Theory, the fine points. This is part 2. And essentially where we left it was that we talked about a superuniverse, a very energetic vacuum giving rise to virtual particles, matter and antimatter, and giving essentially an equation like this, where matter plus antimatter, when they collide, create matter, photons, and antimatter. And I mentioned that you get about 1% more matter. We have found out that you get about 1%. This is 1% more than the antimatter. So the photons are actually being made at the expense of the antimatter. When this goes to completion, what are we going to get? We're essentially going to get this. The antimatter will be consumed completely. We will get matter and electromagnetic radiation, which is photons, and that's the universe we have today. So this equation works. Does that mean there's an asymmetry of physical laws? No. Basically, not in my opinion. Basically, what this is an empirical equation. And from chemistry, it's phenomenological. Most of chemistry is phenomenological. And basically what it's telling us is that in the equation, chemical equation, matter is favored over antimatter. Now, when the two come together, the amount of energy that's given off initially in the electromagnetic energy in the form of photons is a violent reaction. And so this causes the initial inflation, the early inflation, that initial coming together. Now, how do we know that there was an early inflation? This has been studied by looking at the cosmic microwave background. And we find it's extremely uniform, and the only way we can explain that is by saying that initially there was an exponential inflation of energy. What does that mean, an exponential inflation? Well, exponential means first 2 times, 4 times, 6 times, 16 times, etc. It exponentially inflated. A linear inflation would be 1, 2, 3, 4, 5, 6. So basically, it exponentially inflated, and that's because of the amount of energy that was given off. And what we ended up with when the matter and antimatter came together, we ended up with a universe of matter and photons. And that's the universe we observe today. However, although this model, which I've termed the Big Bang Duality theory, explains the origin of the Big Bang, the early inflation, and the missing antimatter, what doesn't it explain? Okay. And this is what I call the Del Monte paradox, which is that each significant scientific discovery results in at least one profound scientific mystery. And that is actually talked about in my new book, Unraveling the Universe's Mysteries. And I discuss it. It's called the Del Monte paradox. What is the big mystery that's left? Well, first off, where did this come from? The superuniverse. Some people call this the bulk. Some people call it the multiverse. So it's been given a lot of different names. You've seen it probably on TV on the Discovery Channel. Basically, it's been given a lot of names. It's the superuniverse, the multiverse, the bulk. I refer to it quite frequently as the bulk in my book, Unraveling the Universe's Mysteries. Now, is the Big Bang theory, the Big Bang theory and the Big Bang duality theory, the only theory of the evolution of the universe? And the answer is no. It's the most widely accepted, and it is the one with the most data, experimental data, backing it up. But there is a competing theory, and there are competing theories, but none has captured the imagination to the extent that the multiverse has. So we're going to be talking about the multiverse and the multiverse theories in the next videos. Now, I want to just point out that in a sense, the Big Bang duality theory is a multiverse theory. So let's talk about that. That even looking at that, the Big Bang as a result of a quantum fluctuation where you have matter and you have antimatter, virtual particles, and these collide to form a Big Bang. That's one Big Bang. But that doesn't preclude other Big Bangs from occurring in the same multiverse. So what is the possibility? The possibility is that there's more than one universe. And I know that's mind-bending, hard to accept, but there is even some empirical evidence that there's more than one universe. Now, can we see other universes? And the answer is no, because we are unable, with today's technology, to look beyond the cosmic microwave background. Our telescopes won't go past that. Our radio telescopes stop at that point. But conceivably, there are other universes. And it's recently published, within about the last year, two scientists have come out, and I've documented it in the book, that have spotted rings on the cosmic microwave background. And they attribute these rings to other universes bumping into ours. So, interesting theory, and one that we'll talk about in upcoming videos. So in our next video, we're going to talk about the multiverse. Thank you.